All right, what's happening? Thank you for actually doing your assignments. I haven't looked at them or graded them yet, but I've seen quite a few come by through my Google Drive. So that's pretty sweet. Thank you for looking at those. Hopefully you had no problems with that. I have been checking my email. Haven't seen anybody directly email me about those yet. So if you do have issues, holler at me. We can figure that out. Today's topic is going to kind of conclude this whole stoichiometric calculations, these big time choo-choo tracks. Concept's called percentage yield. And here's kind of where we have been and where we're going. So the real world of chemistry. You guys know that chemistry is full of lies. I lie to you all the time. It's what I do. Basically, the reason I do that is not because I want to laugh at you. It's because I want you guys to learn little things before we have to learn big things and exceptions to the rules. So where have we been? When we started doing this big choo-choo track map, we were doing calculations where we were taking one number and converting to another. That's called ideal stoichiometry. The idea is that whatever you think you're calculating as a product is what you should get. Then I said, psych. Nice try, guys. But now we have two reactants. We have to figure out which one runs out first, and that thing will determine how much product we get. So the limiting reagent and limiting reactant stuff is what we've been doing the last couple of days. And today, it's psych again. What we're going to do today is we're going to look at real stoichiometry with real yields. Real yields would be like how much we actually get in a chemical reaction. This is tough to do with you guys not in the lab setting because we have something set up for you that you guys could actually run this and you can actually see it, but we can't do that. So you guys just have to take my word for it, and I'll try to give you some examples that will help you out. So today's topic, real stoichiometry with yields. So the concept is, and this is the key, one of the key things in chemistry, what actually happens in a reaction is when you have a reaction, and when a reaction occurs, the amount of stuff that you think you should get never, ever happens. You're always going to get less than you calculate. So like right now, we've been calculating how much product we should get the last few days. And we've just been circling that number and saying, there it is. That's our answer. Let's move on. Well, here's the deal. That is a freaking lie. And we're going to look at why that is today. Okay, so why is this a lie? Well, I'm going to show you guys an example of something that you guys should know about maybe. All right. So why is that a lie? Here's a combustion reaction. If we take any kind of hydrocarbon, let's just take CH4, and we react it with O2. You guys have learned that there are two flavors of this reaction. When this reaction occurs, you get a little bit of this. But here's the key to chemistry is that in a lot of chemical reactions, what you think you're getting 100% of isn't actually happening. Now, this reaction is going to look very similar. These are not balanced. I guess we could balance them real quick. Why balance them? Who cares, right? So here's the deal. The top reaction, if your goal was to make CO2 and H2O, that's sweet. You're getting some of that. But what happens in chemical reactions is you get these little things called side reactions. Side reactions occur, and those are reactions that occur that you don't really think are occurring, and you're getting product that you don't really want. So like when we have complete combustion, but we get a little bit of incomplete combustion, one of the side reaction products is going to be CO. So if the goal is to make as much CO2 as possible, then, and you have this CO being made, that kind of screws up what you guys think. So this is going to be a really stupid example, but I'm just kind of pulling this out of nowhere. Imagine that you have a recipe and you're going to bake a bunch of cakes, all right? Or bake a cake, right? So you mix all this stuff up and you throw it in the oven. And when you pull it out of the oven, somehow 92% of the product was cake. And then you just have like two cookies sitting to the side, which literally makes no sense in the world of baking. That'd be a miracle. But the idea is that where those two cookies come from, they came from a side reaction. So that's going to be kind of what happens on reaction. So the way that we deal with this, the way that we see how this works is we try to figure out how effective this reaction was. And the way we do that is we use a concept called percent yield. Percentage yield is a measurement of how effective your reaction was. So if I do a reaction and I get 95% of the stuff that I wanted, I'd say that was a pretty effective reaction. If I do a reaction and I get 12%, well, then that reaction kind of sucked. And we got to go back to the drawing board and find a better way to do this chemical reaction. So the reaction and that you're doing, like I said, is going to have these weird side reactions that kind of screws up your stuff. Okay. So your percentage is going to be based on two values. The first value is called the actual yield. So say you were in the lab, say you did a reaction and you measured how much stuff you actually got. This is going to be your actual yield. This would be, for example, to go back to the terrible cake example, this would be that 92% of the cake that you actually got. Well, what we theoretically calculated is we should have got a whole cake there. And that's what we've been calculating. It's called the theoretical yield. What we've been calculating in terms of the last few weeks. What we should get is always the theoretical yield. So, pro tip here. In the problems that you guys are going to be presented with, the actual yield is going to be the product that's going to be written in the problem. The theoretical yield is going to be the product that you're actually calculating or that you're going to calculate out. So that's going to be something that you guys can look for, and I'll show you guys how to do that today. At least that's my goal. All right. So we calculate percentage yield. To find percentage yield, when you get to this point of having both product amounts, you're going to use the following idea. Okay. So calculate percentage yield. You're going to take what you actually got all over the theoretical amount. And then we can make it a percentage, move the decimal 2 places, or multiply by 100. I don't want you guys to freak out too much about that. So if we did a reaction and our goal is to make, let's make some NH3, some ammonia. And we made 5 grams is what we actually got. And we should have made, 10 grams. We're going to use nice numbers here. So 5 divided by 10 times 150% yield. That's kind of the idea on how this stuff works. So the problems that you guys are going to be faced with are going to be broken into 3 different flavors. So the 3 flavors of problems that you have, we've got mild, medium, and spicy. And the flavors that you guys are going to deal with don't really deal with, difficulty. There's just more steps in the spicy than there are the mild and the medium. So I'm going to show you guys what to look for when you do these reactions. So when we do percentage yields, we're going to start with a mild problem here. Here's our example. We want to find the yield if a reaction gives you 15.5 grams of product, but you expected 19.8 grams of product. So we ran the reaction. We measured the stuff that we got at the end. We got 15.5 is what we actually got. But when we were doing our calculations, we should have gotten 19.8 grams of product. So question is, what's our percentage yield here? Well, here's the key. The key to this is that I'm going to have to pause this video here because my wife is calling me. All right, we're back. Sorry about that. My wife said she was the worst for interrupting me there, but this is life, guys. Whatever, right? Stuff happens. So let's see here. Where were we at? We were going to solve this mild problem here. And the key is that you were given 2 products. So for us, when we calculate this, here's what we're going to do. You're just going to take the little number and divide the little number by the big number and then make it a percentage. Okay. So I will show you guys this example on the board here. Like I said, what you guys are going to start looking for is what I'm given a reactant or a product. So for this one, because it says product and product, you go, thank you, Mr. Shaw, for the very nice problem. This is super mild, good flavor, but super mild. There's your setup for how to calculate that first percentage. So you take 15.5 divided by 19.8, and you make a percentage, and we round to whatever number of sig figs those guys have. So we have 3 and 3. So it looks like this is going to be 78.3% yield there. Is that good? I don't know. Sure, it's great. Or it's terrible, depending on what you are. Are you Walter White? All right. You want that 95, 97%, or are you just a random person in a chemistry lab trying to make random chemical? I don't know. Whatever. So that's kind of the idea behind that one, right? So that was mild. Let's go to the medium. So let's just skip down here and just start right this. Okay. So what's a medium problem look like? Medium problem looks like this. You have 34 moles of O2 and it produces 55 moles of H2O. Find the percent yield. Now, the nice thing about percent yield is that when you get to that last step, if you can get them in the same measurement, then you can do the division. If you calculate one thing to grams and one thing to moles, then you got to deal with it. Okay. So here's what I want you guys to see. I want you to see. Let's see if I can do this little pointer thing. That is classy. All right. So what you're given is you're given moles of O2, which is a reactant, and you're given 55 moles of water, which is a product. So here is the key that this is a medium problem. The key to a medium problem, all right, say 51, looks like second hour is beginning, so that's cool. Here's the key to a medium problem. See a reactant, see one product. We're going to roll from there, okay? So how do we do this? Well, we're going to do this as follows. You're going to convert the reactant to the product, and you have to make sure you pay attention to the labels of the product in your problem. I'll show you guys this. So take that reactant, convert it to the product that was given to you in the problem. So since it was water, we want to convert to moles of water. And then we just take the smaller number divided by the bigger number. That's all we have to do here, okay? I will show you guys these steps on this here. Okay. So try this. All right. So here's what we're going to do. I see a reactant. I see a product. We'll come back to that product. But here's what I want you guys to notice. It is in moles of water. So what we have to do is we have to take this 34 moles of O2, and we're going to convert that to moles of water. So the mole ratio is 1 to 2. 1 mole of O2, 2 moles of H2O. Okay, so we take 34 times 2, we get 68 moles. Now, what does this represent? This represents how much water we should have got. We did the reaction, and we only got 55 moles of water, 55 out of 68. So second step, take the little number, take what you actually got, divided by the theoretical yield, and multiply by 100. So our answer for this problem is going to be 55, 68, 3 sig figs, so 80.9% yield. That's your answer right there, okay? Medium problem. Why is it different from mild? Well, mild, we just took one little number and we divided by the big number. Medium, we had to do one conversion. So one conversion is what makes that a medium problem, okay? So let's go to the spicy. All right, so what makes something spicy? Well, like I said, it's kind of putting everything together, putting all of this stuff together. So we have this problem where we're going to do the water reaction again. We take 6.4 grams of hydrogen. It reacts with 25 grams of O2. If the actual yield of water is 5 grams, what's the percentage yield? So like up until now, we've never had a problem where it has so many numbers here. So that sucks. So how are we going to deal with this? All right. So here's the key, the pro tip. You're given 2 reactants and 1 product. If you see that, you'll know it's spicy. So you can use the steps I'm going to give you in a second. All right. So 6.4 grams of hydrogen, that's a reactant. 25 grams of O2, that's a reactant. 5 grams of water, that's a product. 2 reactants, 1 product. Enjoying the wonderful world of the spicy reaction. Okay, so what does this mean? This is stuff that you guys have done. Whenever we're given 2 reactants, we kind of have to do that limited reagent thing. But we're going to boil it down for you a little bit easier, just to kind of simplify this for you, since there's so much action, so much stuff going on, right? So step 1, convert both reactants to the product. In this case, we'd want to convert to grams of water, because that was given to us in the problem. The second step, pick the smaller amount. Whatever amount of water you got, I want you to circle that one, and the bigger number of water that you calculated, I want you to cross that off, because that's dead to us. We don't care about that, okay? So out of our 2 answers from step 1, we're going to circle the smaller amount, because that was made by the limiting reagent, okay? Now what we've effectively done is we've created a mild problem. We have the grams of water given to us in the problem. We have the grams of water that we just calculated and we circled. Divide the actual yield by your answer from step 2 and make it a percentage. That's how we're going to do it, okay? So that is how a spicy problem works. So I'll go ahead and bust this spicy problem out for you, and then just kind of turn you loose here on this stuff. Maybe. Let's see here. Okay, so spicy problem. So reactant, product. We'll deal with that product later. Step 1, take both of these reactants and convert it to this product. The product is grams of water. So I'm going to do each one right here. 6.4 grams of hydrogen. We got so many steps here. 2 grams of hydrogen, 1 mole. Hydrogen, let's try to get out of the way. It is a 2 to 2 ratio because of the reaction, and 1 mole of water is equal to 18 grams. Okay, so that's that one. We're going to take 25 grams of oxygen. We're going to convert that, 1 mole of O2. Nice thing about doing this on a video, not in class, is you can push pause, right? I mean, that's kind of nice. And I don't know. Not that I don't miss you guys. I do. Make sure you're washing your hands and not going out like the idiots in spring break in Florida. All right, can you do that for me? That'd be great. All right, here we go. So we've got these values here. I'm going to do the top one first. Times 2 times 18 divided by 32. Okay, so this reaction said I should have got 28 grams of water. Okay, so there's the first one. The bottom one says that I should have gotten, whoa, not even close, 57.6 grams of water, right? So yeah, that's really pretty. 57.6 grams of water. All right, so here's what you're going to do. You're going to shank that guy, and we're going to circle that guy. Now it is a mild problem. Here's how it's a mild problem. Man, we suck at chemistry if this is our yield, because we got 5 grams, but we should have got 28 grams. Uh-oh. If you take quantitative chemistry, that is going to be a bad grade for you when you get a 17, actually 2 sig figs, 18% yield. Wah, wah. All right? So that's how you do a spicy problem. I'm sure that looks like a bunch of gibberish. Email me if you have questions. I will post on Classroom a kind of worksheet or whatnot that you guys can make a copy of, or you can just take a picture and upload your answers. That doesn't matter to me. I don't really care. There you go. That's a real stoichiometry with real yields. So holler at me if you have questions.